May 18th, 1980, at 8:32 a.m., a report was radioed from this ridge. The report was Vancouver, Vancouver, this is it. And Mount Saint Helens exploded.
When the world is already on the brink of wars raging, UFO sightings, and global warming, something far more terrifying has emerged with a sense of urgent attention. Deep beneath the Pacific Ocean, near the restless Mount Saint Helens, a mysterious leak is releasing gases from the Earth's molten heart.
It's almost like you have your coffee cup, it's too hot, and you just blow on it. And you create waves on the surface.
What does this mean for us? Is it a warning sign of something bigger? Scientists are racing against time, deploying the best possible technology to reveal its secrets. But every second counts. Could this be the beginning of an unstoppable chain reaction? Let's discover together. Mount Saint Helens and global warming. Mount Saint Helens has long been a symbol of nature's raw and unpredictable power. Its eruption in the early 80s seared itself into the collective memory, a fiery display of chaos that painted the skies with ash and devastation. But now the focus has quietly shifted, and what lies beneath the surface, far below the ocean waves near its volcanic shadow, has become the source of a new and chilling mystery. Here in the pitch-black depths, discoveries are being made that have left scientists both in awe and deeply unsettled. The melting polar glaciers, distant and detached from this landscape, have somehow become players in this hidden drama. These towering ice masses, as they succumb to the relentless heat of a warming planet, are doing more than just raising sea levels. They are altering the planet itself. The weight they once imposed on the Earth's crust is vanishing, releasing a pressure that has been building for millennia. This change is subtle, invisible to the naked eye, but its effects are profound. It shifts the balance of the Earth's center of gravity, nudging tectonic plates into motion like restless giants stirring in their sleep. The ramifications of this are beyond unsettling. They're terrifying. The ocean floor near Mount Saint Helens has become a new frontier in understanding these changes. This is no ordinary exploration. It's a race against forces we can barely comprehend. Cutting-edge underwater robotics are descending into the abyss, their lights piercing the suffocating darkness as they map the terrain and collect data. Thermal imaging systems capture faint hints of heat where there should be none, while seismic monitors listen to the planet's whispers, small tremors that might foretell far greater events. But there's a grim weight to all this progress. These tools are not merely instruments of science. They are the desperate hands of humanity grasping for answers in a world that seems increasingly volatile and unpredictable. What they are finding is as unsettling as it is extraordinary. The interplay between climate change and geological forces is creating a scenario no one anticipated. The slow, steady warming of the planet is doing more than reshaping coastlines or intensifying storms. It's stirring the very foundations of the Earth. Tectonic plates, once thought stable in certain regions, are now moving in unexpected ways. The crust, freed from the crushing weight of ancient glaciers, is beginning to shift, searching for a new balance. And when the Earth moves, it rarely does so quietly. There is something deeply unsettling about these discoveries. The ocean floor, a place that has long hidden its secrets beneath miles of crushing pressure and impenetrable darkness, is revealing a story of profound upheaval. Each piece of data collected feels like a small warning, a faint echo of something far larger and more dangerous to come. The tremors detected here may be the precursors to earthquakes or volcanic eruptions in places we least expect. The questions linger, unspoken but undeniable. What will be the next domino to fall? And how much time do we have before it does? As scientists delve deeper into this underwater world, unease follows them. These aren't just researchers, but explorers standing on the edge of an abyss, staring into the unknown with determination and dread. The stakes are impossible to ignore. What they discover here could redefine our understanding of the planet and perhaps even offer solutions to challenges we have yet to face. But there is also the chilling possibility that these answers may confirm our worst fears, that we are too late, that the Earth's immense forces are already in motion, unstoppable and indifferent to our efforts. This is not a story of triumph or conquest. It is one of humility and frailty, of humanity recognizing the limits of its understanding in the face of an ancient, untamed world. The ocean's depths are not merely a frontier for exploration, they are a reminder of how much we have yet to learn about the planet that sustains us. Each discovery feels like peeling back a layer of mystery, only to find an even darker truth lurking beneath. The technologies we've built, as advanced and sophisticated as they are, feel almost fragile in the face of these immense forces. It's as if we are children trying to decipher a language far older and more complex than anything we've ever known. Yet despite the fear, there is hope. Hope that buried within this mystery lies the key to understanding and perhaps even mitigating the volatile forces that threaten us. The data streaming back from these underwater missions is more than just numbers and charts. It's a lifeline, a chance to glimpse what the future might hold and prepare for it. But the hope is fragile, balanced precariously on the edge of a realization that grows harder to ignore with every passing day. The Earth is moving, shifting, and evolving in ways we can barely comprehend, and we are struggling to keep pace. The ocean floor is more than a geological curiosity. It is a place where humanity's resilience is being tested. What lies beneath the surface may hold answers to questions we didn't know we needed to ask. It may offer warnings of dangers we have yet to face. But it also serves as a stark reminder of our place in the grand, unforgiving order of nature. As scientists push further into this mysterious realm, they are haunted by a truth as old as the planet itself. The Earth does not bend to our will. It moves on its terms, and we can only hope to understand enough to survive its changes. Yet now it's not the peak that commands attention, but the ocean floor nearby, where an unsettling discovery has emerged. Hidden in the deep, a leak is releasing a toxic mix of gases, methane, carbon dioxide, and others that rise from the sea floor like ghostly whispers from the planet's core. This isn't just a geological curiosity. This is a warning sign, a glimpse into something far larger and far more dangerous. A leak of volcanic proportions. While its connection to deep magma reservoirs has stirred widespread concern, what sets this challenge apart is the remarkable effort to turn fear into action. At the heart of this mission lies a convergence of cutting-edge technology and human ingenuity, as experts work to tame the volatile forces of nature before they escalate into catastrophe. The leak, a slow and steady stream of methane, carbon dioxide, and other volcanic gases, is a phenomenon that could once have left us feeling helpless. But today, the tools at our disposal allow us to confront it with unprecedented precision. Submersible robots, engineered to withstand crushing pressures and extreme temperatures, are mapping the sea floor around the vent. These advanced machines gather high-resolution imagery, measure gas flow rates, and collect critical samples, providing scientists with a detailed understanding of the leak's behavior. Thermal imaging systems deployed from research vessels paint a vivid picture of the heat signatures surrounding the leak. These data help identify subtle changes in temperature that might signal shifts in magma activity deep below the surface. Seismic sensors, positioned strategically on the ocean floor, listen intently for tremors that might indicate the shifting of tectonic plates or the movement of magma. Together, these tools form a comprehensive surveillance network, capturing every whisper of the Earth's restless interior. The gases themselves are being studied with a level of precision unimaginable just decades ago. Isotopic analysis allows scientists to trace their origins, linking them to specific geological processes. This isn't just about understanding what's happening now. It's about predicting what might come next. If the composition of the gases changes, it could signal an increase in pressure or temperature below, providing an early warning system for potential eruptions or seismic events. But this effort isn't limited to monitoring. Engineers and geoscientists are exploring ways to intervene if the leak shows signs of destabilizing. One approach involves the potential use of deep-sea drilling to relieve pressure in a controlled manner. By creating alternative pathways for gas to escape, it might be possible to manage the system and prevent a sudden and catastrophic release. While this concept is still in its infancy, it demonstrates the kind of bold thinking required to address challenges of this magnitude. Climate scientists are also heavily involved, recognizing that the leak has implications far beyond the Pacific Northwest. Methane, a potent greenhouse gas, poses a significant risk to the atmosphere if it escapes in large quantities. Researchers are working on innovative containment methods, such as capturing the gas at its source and converting it into less harmful compounds. This dual-purpose strategy not only reduces the immediate geological threat, but also mitigates the broader impact on global warming. The collaboration across disciplines is unprecedented. Oceanographers, geologists, engineers, and climate experts are pooling their knowledge, each contributing a piece to the puzzle. Governments and international organizations are providing funding and logistical support, acknowledging the global stakes of this local phenomenon. Private tech companies with their expertise in robotics and data analytics are also stepping up, pushing the boundaries of what's possible in underwater exploration and control. Despite these efforts, the challenges are immense. The environment surrounding the leak is as hostile as it is fascinating. The crushing pressure of the deep sea, combined with the intense heat of volcanic activity, makes it one of the most difficult places on Earth to work. Equipment must be designed to withstand these extremes, and the data collected must be interpreted with care, as even small errors could lead to false conclusions. Yet for all the obstacles, the progress being made is remarkable. Technologies developed for this effort are already finding applications in other fields. The same robotics used to explore the seafloor are being adapted for use in space exploration and deep mining operations. Innovations in gas capture are being integrated into carbon sequestration projects, offering new ways to combat climate change. This leak, as daunting as it may be, has become a catalyst for technological advancement, driving humanity to new heights of understanding and capability. The gases themselves tell a story, though one not easily interpreted. Methane and carbon dioxide, while common in volcanic systems, are potent in ways that go beyond geology. Their release into the ocean and eventually into the atmosphere feeds into the cycle of climate change, adding another layer of complexity to an already dire situation. The Earth's systems are connected in ways we are only beginning to understand, and this leak is a stark reminder of those connections. The forces driving it are ancient, but their effects ripple through the modern world, touching everything from the air we breathe to the ground we walk on. What secrets lie within the ocean floor leak near Mount Saint Helens? And why has its discovery terrified the scientific community? Could its proximity to the Cascadia subduction zone signal an impending disaster? What hidden truths are carried within the gases it emits? And how do they connect to larger threats spanning from the ocean depths to the atmosphere above? The Cascadia connection. The Cascadia subduction zone has long been recognized as one of the most dangerous tectonic regions on Earth, but this discovery makes its threat feel immediate. The leak is not just a geological oddity, it's a signpost, pointing to dangers that can no longer be ignored. The magma below Mount Saint Helens, the grinding plates of the subduction zone, and the chain of volcanoes stretching across the Pacific Northwest are all part of the same story. And that story is one of immense pressure, growing strain, and the potential for catastrophic release. The ocean floor, often thought of as a place of quiet mystery, now feels like the center of a storm waiting to break. The leak is small in size but enormous in meaning, a window into forces that could reshape the world in an instant. It's a reminder of the Earth's immense power, a power that operates on a scale far beyond human comprehension. And as we watch and study, trying to make sense of it all, one truth becomes increasingly clear. The Earth will move when it chooses, and all we can do is try to understand it before it does. Methane seeps steadily from the leak, its presence a quiet but potent warning. This gas is far more dangerous than carbon dioxide, trapping heat with a ferocity that makes even small amounts a significant concern. As it rises into the water column, it threatens to disturb the methane hydrate deposits that have lain frozen beneath the ocean floor for millennia. These deposits, vast and volatile, represent a sleeping giant of greenhouse gas emissions. The warming oceans are already chipping away at their icy stability, and this leak adds another layer of risk. A sudden release could flood the atmosphere with methane, accelerating climate change in ways that are both rapid and devastating. The connection between the leak and the Cascadia subduction zone only deepens the sense of unease. This fault line is a geological time bomb, its plates locked in a tense embrace that stores unimaginable amounts of energy. A rupture here would not only unleash violent earthquakes and towering tsunamis, but could also disturb the fragile balance of methane hydrates along the ocean floor. The seismic upheaval could trigger cascading releases of gas, transforming a geological disaster into a global climate crisis. It's a chilling reminder of how tightly the Earth's systems are woven together, and how quickly one disturbance can spiral into chaos. As researchers study the leak, their findings paint an increasingly urgent picture. The gases escaping from the sea floor aren't just a snapshot of volcanic activity. They're a glimpse into a complex network of interactions between geology, oceanography, and the atmosphere. The methane released here doesn't stay confined to the deep. It rises, dissolves, and eventually escapes into the air, where it lingers and traps heat. This isn't a local issue, it's a planetary one. The climate implications of such emissions are profound, and they underscore the need to understand this phenomenon before it grows beyond our ability to manage. The feedback loop this leak could trigger is particularly alarming. As methane escapes into the atmosphere, it contributes to global warming, which in turn heats the oceans further. Warmer waters destabilize more methane hydrates, releasing even greater quantities of gas. It's a chain reaction that feeds itself, a cycle that threatens to spiral out of control. This isn't just a theoretical risk, it's a reality we're edging closer to with each passing year. The oceans, long regarded as a buffer for the planet's excess heat, are reaching their limits. And the gases escaping near Mount Saint Helens are a stark indicator of what lies ahead. The ecological impacts of such a release would be profound. Marine life, already struggling with warming waters and acidification, would face yet another challenge as methane disrupts oxygen levels and alters ecosystems. Coral reefs, vital to countless species, could suffer further bleaching and collapse. Fish populations could dwindle, affecting food supplies for millions of people. On land, the effects would be equally devastating. Rising temperatures would fuel more extreme weather events, hurricanes, droughts, and floods, disrupting communities and infrastructure. The ripple effects would touch every corner of the globe, leaving no one untouched by the consequences of this hidden threat. Efforts to monitor the leak have taken on a new urgency. Sophisticated tools are being deployed to capture data on gas composition, flow rates, and the surrounding geology. Each piece of information adds to a growing understanding of the dangers posed by this phenomenon. Yet even with these advancements, the ocean floor remains an enigmatic and treacherous frontier. The forces at work here are ancient and immense, and our ability to predict their next move is still limited. It's a race against time and the unknown, with the fate of ecosystems, economies, and lives hanging in the balance. As the Earth continues to warm and its geological systems respond, the challenges we face will only grow. The gases escaping from the ocean floor are a symbol of a planet in flux, a sign that the balance we rely on is shifting. The interplay between the Cascadia subduction zone, the methane hydrates, and the warming oceans is a complex and dangerous dance. It's a reminder of how fragile our place on this planet truly is, and how urgently we must act to understand and mitigate the risks before they overtake us. The discovery of this leak is not just a scientific breakthrough, it's a wake-up call. The forces it represents are vast and interconnected, their effects reaching far beyond the Pacific Northwest. This isn't just about Mount Saint Helens or even the Cascadia subduction zone. It's about the fragile balance of a planet under stress and the choices we must make to protect it. The leak is small, but its implications are immense. And as it quietly continues its release, it forces us to confront the reality of a world that is changing faster than we ever imagined. What secrets does the mysterious leak near Mount Saint Helens hold? And how does it connect to the Earth's hidden depths? Could the traces of isotopes point to a direct link with the deep mantle, where ancient materials are forged under unimaginable heat and pressure? What forces are at play beneath our feet, and what do they reveal about the dynamic inner workings of our planet? A geothermal puzzle with global stakes, the mysterious leak near Mount Saint Helens has opened a window into the Earth's hidden depths, revealing forces that defy easy explanation. Traces of isotopes suggest a direct link to the deep mantle, where ancient materials churn in unimaginable heat and pressure. The possibility of a massive superplume rising beneath the Pacific Northwest has scientists grappling with questions that could reshape our understanding of geology. This isn't just about one region. The implications of such a discovery stretch far beyond, touching every corner of the planet and forcing us to confront the delicate balance that sustains life on Earth. The mantle, vast and enigmatic, holds secrets older than time itself. If a superplume is indeed stirring beneath Mount Saint Helens, it represents a colossal wellspring of molten rock and energy, one capable of influencing tectonic activity across the region. Such a phenomenon could explain not only the volatile nature of the Pacific Northwest, but also the strange connection between volcanic activity and the ocean floor leak. This is a puzzle with pieces scattered across time and space, and each new discovery adds both clarity and confusion to the picture. Global warming adds another layer of complexity to this already intricate scenario. The planet's melting glaciers, shedding ice at an accelerating pace, are altering the distribution of mass on the Earth's surface. These changes, seemingly distant from volcanic activity, are anything but trivial. They shift the planet's center of gravity, causing subtle but significant changes to the forces acting on tectonic plates. In regions like the Pacific Northwest, where geological stress is already high, these shifts could act as a catalyst, tipping the scales and intensifying activity deep below the surface. It's not just the melting ice that has scientists worried limits what comes next. The interplay between a warming climate and geological forces is a feedback loop that's only beginning to reveal itself. As glaciers recede, the land beneath them rises, a phenomenon known as isostatic rebound. This movement, imperceptible to the human eye, can destabilize nearby fault lines, leading to earthquakes and potentially awakening dormant volcanic systems. The leak near Mount Saint Helens might be one of the first signs of this delicate balance unraveling, its steady release of gases, a faint echo of the pressures building far below. In their efforts to understand these forces, researchers are pushing the boundaries of technology. Advanced robotics are venturing into the ocean's depths, mapping the seafloor with unprecedented precision. Instruments capable of detecting minute isotopic differences are shedding light on the origins of the gases escaping from the leak. Thermal imaging systems are peering into the volcano's heart, tracking the movement of magma with eerie clarity. Each breakthrough brings us closer to understanding the forces at play, yet the deeper we look, the more we realize how much remains unknown. The presence of isotopes linked to deep mantle activity is a particularly troubling clue. These chemical fingerprints point to processes occurring miles beneath the Earth's crust, where temperatures and pressures are beyond anything we can replicate. If the leak is connected to a superplume, it suggests a scale of geological activity that could have far-reaching consequences. Superplumes are not gentle phenomena. They are vast, dynamic upwellings of molten rock, capable of reshaping landscapes and altering climates. Their influence extends beyond eruptions and earthquakes, affecting atmospheric conditions and even ocean currents. The Pacific Northwest sits precariously at the crossroads of these forces. It is a region of striking natural beauty, yet its landscapes are shaped by destruction. The Cascadia subduction zone lies just offshore, a fault line capable of generating earthquakes more powerful than any in recorded history. Mount Saint Helens and its neighboring peaks are part of a volcanic arc that has erupted repeatedly over millennia. Now, with the discovery of the leak and the possibility of a superplume beneath it, this already volatile region faces new uncertainties. Every discovery at the site of the leak brings us closer to answers, but it also raises new questions. The possibility of a superplume, the role of melting glaciers, the feedback loop of warming, and geological activity. Each is a thread in a larger tapestry of interconnected systems. The Pacific Northwest may be the current epicenter, but the implications stretch far beyond. What happens here will resonate across the globe, shaping not just the landscapes we inhabit, but the way we understand our place within them. The Earth is speaking, its message carried by the gases rising from the ocean floor and the trembling of its tectonic plates. It is a reminder of the immense forces that surround us, forces we can neither predict nor control. Yet it is also a call to action, a challenge to look deeper, think broader, and prepare for the future. The leak near Mount Saint Helens may be a mystery, but it is one we cannot afford to ignore. As the leak near Mount Saint Helens continues to reveal its chilling secrets, the clock is ticking on humanity's ability to control the forces at play beneath the ocean floor. This isn't just about protecting one region, it's about safeguarding our entire planet from a disaster that could change everything. The technologies we've developed are our best hope, but time and uncertainty are not on our side. We're standing on the edge of an unimaginable crisis, and how we respond could define the future of life on Earth. So what do you think? Are we truly ready to face this unseen threat? Or will we be overwhelmed by the planet's raw power?